Look up at the night sky. What do you see? Is it just a blanket of darkness dotted with tiny lights, or is it something more? Thousands of stars twinkle above us, each one a beacon of light in the vast expanse of space. They form constellations, patterns that have guided sailors and inspired storytellers for millennia. Each star is a distant sun, just like our own, burning brightly in the cold vacuum of space. Some are much larger, others smaller, but all are part of the cosmic tapestry. Now imagine all the stars you can't see, hidden from view by cosmic dust or simply too far away. The universe is teeming with stars, many of which remain invisible to the naked eye. Our universe is vast and full of mystery. It's a place where the laws of physics as we know them are constantly being tested and sometimes even broken. Could we be alone in this vast expanse? This question has haunted humanity for as long as we've looked up at the stars. Or is there life out there, somewhere among the stars? Planets orbit many of these distant suns, and some of them might harbor conditions suitable for life. The thought of extraterrestrial life, life beyond Earth, has fascinated humans for centuries. Ancient civilizations looked to the skies and wondered if we were alone. It's a question that sparks our curiosity and ignites our imagination. From scientists to dreamers, the idea of life beyond our planet captivates us all. The search for extraterrestrial life is a search for ourselves. It's a quest to understand not just if we are alone, but what it means to be alive in this universe. It's a quest to understand our place in the grand scheme of the cosmos. Are we a unique phenomenon or just one of many forms of life scattered across the stars? It's a journey that takes us from the depths of our oceans to the farthest reaches of space. Both realms are filled with unknowns, waiting to be discovered. And it all begins with a simple question. Are we alone? This question drives us to explore, to seek, and to understand the universe and our place within it. Our Sun is just one star among billions in the Milky Way galaxy. It's a part of a vast cosmic neighborhood that stretches far beyond what the naked eye can see. Imagine a giant swirling city of stars. Each star is like a building, and together they form a magnificent luminous metropolis. That's the Milky Way. It's shaped like a disc with spiral arms that extend outward like a pinwheel. These arms are filled with stars, planets, gas and dust, all rotating around a central bulge. Our solar system sits on one of these arms about halfway from the center. This arm is known as the Orion Arm, a relatively small and quiet neighborhood in the grand scheme of the galaxy. When we look up at the night sky, we're seeing the Milky Way from the inside. The band of light stretching across the sky is actually the dense concentration of stars in the galactic plane. It's a breathtaking sight, filled with countless stars and the faint glow of gas and dust. These elements come together to create the beautiful hazy band of light that has fascinated humans for millennia. The Milky Way is so vast that it's hard to grasp its true size. If you could travel at the speed of light, it would still take you about 100,000 years to cross from one side to the other. Light, traveling at an incredible speed of about 300,000 kilometers per second, takes a staggering amount of time to traverse our galaxy. This gives us a sense of just how immense the Milky Way truly is. Within this vast galactic city, there are billions upon billions of stars, each with its own story to tell. Some stars are similar to our Sun, while others are much larger or smaller, hotter or cooler. Each one contributes to the rich tapestry of the Milky Way. Stars are born in vast clouds of gas and dust called nebulae. Over millions of years, gravity pulls these materials together to form new stars, continuing the cycle of creation and destruction that shapes our galaxy. Some stars end their lives in spectacular explosions known as supernovae. These events scatter elements into space, enriching the galaxy and providing the building blocks for new stars and planets. At the very center of the Milky Way lies a supermassive black hole, millions of times the mass of our Sun. This mysterious object exerts a powerful gravitational pull, influencing the orbits of stars and shaping the structure of our galaxy. The Milky Way is a dynamic and ever-changing entity, a cosmic dance of stars, gas, and dust. It's a reminder of the vastness of the universe and our small but significant place within it. Many stars have planets orbiting them, just like our Sun. We call these planets exoplanets. Some exoplanets are similar in size and composition to Earth. They orbit their stars within a special zone called the habitable zone. The habitable zone is the region around a star where temperatures are just right for liquid water to exist on the surface of a planet. Water is essential for life as we know it, so finding planets in the habitable zone is a big deal. It means that these planets could potentially support life. Think about all those stars in the Milky Way. Now imagine a fraction of those stars having planets, and then imagine a fraction of those planets being located in the habitable zone. The numbers are staggering. Section 4, searching for life in our solar system. We don't have to look beyond our solar system to search for life. Right here in our cosmic backyard, there are intriguing places that could harbor life. Take Europa, for instance. Europa is a moon of Jupiter, and it's covered in a thick layer of ice. But beneath that icy shell, scientists believe there's a vast ocean of liquid water. This ocean could be twice the volume of all the oceans on Earth combined, and where there's water, there could be life. Another promising candidate is Enceladus, a moon of Saturn. Enceladus also has an icy surface, but it's even more intriguing because it has geysers that erupt from its south polar region. These geysers spew water vapor and organic molecules into space, hinting at a potential subsurface ocean. Section 5, exoplanets, worlds beyond our sun. Beyond our solar system, astronomers have discovered thousands of exoplanets. These discoveries have revolutionized our understanding of planetary systems and the potential for life beyond Earth. Some exoplanets are gas giants, much larger than Jupiter. Others are rocky planets like Earth, but much hotter or colder. One way astronomers find exoplanets is by looking for tiny dips in the brightness of a star. When a planet passes in front of its star, it blocks a small amount of the star's light. By measuring these dips in brightness, astronomers can infer the presence of a planet. Another method is to look for the wobble of a star caused by the gravitational pull of an orbiting planet. By analyzing the wobble, astronomers can determine the mass and orbit of the planet. Section 6. The Drake equation, calculating the odds. The Drake equation is a fascinating tool that has intrigued scientists and enthusiasts alike for decades. It serves as a framework for understanding the potential for life beyond our planet. In 1961, astronomer Frank Drake came up with an equation to estimate the number of detectable civilizations in our galaxy. This groundbreaking idea was born out of a desire to quantify the unknown and to bring a scientific approach to the age-old question, are we alone in the universe? The Drake equation takes into account factors such as the rate of star formation, which is a crucial starting point. Stars are the birthplaces of planets, and understanding how frequently they form sets the stage for the rest of the equation. The fraction of stars with planets, which has become a more exciting field of study with the discovery of thousands of exoplanets in recent years. These discoveries have shown that planets are more common than we once thought. The number of habitable planets per star, which narrows down the search to those planets that lie within the habitable zone, where conditions might be just right for life as we know it to exist, and the likelihood of life arising on a suitable planet. This factor delves into the realm of biology and the conditions necessary for life to begin and thrive. It also considers the fraction of intelligent civilizations that develop technology capable of interstellar communication. This is a significant leap, as it assumes not only the emergence of life, but also the development of intelligence and technology, and the length of time such civilizations release detectable signals into space. This factor introduces the concept of the window of detectability, which is the period during which a civilization's signals can be detected by others. While the Drake equation doesn't give us a definitive answer, it provides a structured way to approach the question. It encourages us to think critically about the various factors that could influence the existence of extraterrestrial intelligence. It helps us think about the factors that influence the possibility of finding extraterrestrial intelligence. By breaking down the problem into smaller, more manageable parts, the Drake equation allows us to tackle the unknown in a systematic way. The Drake equation is more of a thought experiment than a precise calculation. It serves as a starting point for discussions and further research, rather than providing concrete numbers. Many of the variables are still unknown, and this uncertainty is both a challenge and an opportunity. It highlights the gaps in our knowledge and the areas where more research is needed. So the results can vary widely depending on the assumptions made. Different scientists might use different values for the variables, leading to a wide range of possible outcomes. However, even conservative estimates suggest that there could be many civilizations out there. The vastness of the universe and the sheer number of stars and planets make it seem almost inevitable that we are not alone. The Drake equation continues to inspire and challenge us, pushing the boundaries of our understanding and fueling our curiosity about the cosmos. It reminds us that the search for extraterrestrial intelligence is not just about finding other civilizations, but also about understanding our place in the universe. As we continue to explore the stars and gather more data, the variables in the Drake equation may become clearer, bringing us closer to answering one of humanity's most profound questions. Until then, the Drake equation remains a powerful tool for scientific inquiry and a symbol of our enduring quest to understand the cosmos and our place within it.